Okay, example 5. Two radio transmitters are positioned along a coastline 500 miles apart. Using a LORAN system, a ship determines that a radio signal from transmitter T1 reaches the ship 1600 microseconds before it receives a simultaneous signal from transmitter T2. So let's real quick take a look at the scenario here. Transmitter T1, transmitter T2 are 500 miles apart on the coastline. And the ship is receiving signals from both transmitters. There's a discrepancy in time between the transmissions of 1600 microseconds. There's some computer on board that can establish the exact time it takes for those signals to get there, down to the microsecond. And it says, find an equation of hyperbola with foci located at T1 and T2 on which the ship lies. Assume the radio signal travels at 0.186 miles per microsecond. First off, let's just always assume that our center is going to be 0, 0 for the sake of these problems. All right? We'll assume the coastline is straight. No curvature to it, it's just a nice flat straight coastline there. Alright, so 0, 0, and the transmitters are equally spaced away from the center of this hyperbola. Alright. And the way this LORAN system works is it keeps the ship on a hyperbolic trajectory. So as long as the ship captain keeps the discrepancy between the two signals at 1600 microseconds, then the ship is going to stay on a hyperbolic path. This represents the position of the ship at any given point, right? So that's what's happening there. So the place where the ship's going to be hitting the coastline, hopefully there's a harbor there or something for him to go into. I can have some terrible thing happen to the ship captain, but we have the ability, keeping that 1600 microsecond difference in those transmissions, we can guide the path safely to wherever we needed to go. Okay. So the first thing I want to do is I want to establish the place this is. I want to establish what A is. So from here to here is A, right? We already know that C is equal to 250. Since these are focal points, the transmitters are the focal points. So half of 500 is 250. If I can figure out what A is, then I can figure out what B is because I know that A squared plus B squared equals C squared. I already know that my structure of my equation is going to be x squared over A squared plus y squared over B squared is equal to 1. Because again, I'm letting 0, 0 be the center, so x minus 0, y minus 0 are what they are. Now, I want to get some distances here because A is going to be a distance, not a time. Okay, so there's 1600 microseconds is the discrepancy. So I know that distance equals rate times time. The rate of signal speed is 0.186 miles per microsecond. That's the speed of light. Okay. You might be thinking radio waves being sound, right? If it was somebody playing a radio, that's a sound wave. If they're sending signals of radio signals through the air, they travel at the speed of light. Okay. So the rate of speed of sound, speed of light here is 0.186 miles per microsecond. In case you're curious, it's µs, microsecond. Greek letter mu. Right. Times 1600 microseconds. Rate times time equals distance, microseconds cancel. And whatever 0.186 times 1600 is, 0.186 times 1600 comes out to 297.6. Hey, what that represents is not A. Imagine this hyperbola. Here's the other half of the hyperbola, right? Okay. What that 297.6 represents is 2A. It represents the length of the transverse axis. All right. So if 2A is 297.6, therefore A would be half of that, so 148.8. We already know C is equal to 250 miles. And the only thing I needed beyond that is what B is, right? And I know A squared plus B squared equals C squared. So 148.8 squared plus B squared is equal to 250 squared. So B squared is going to be 250 squared minus 148.8 squared. Calculator out again. 250 squared minus 148.8 squared comes out to 40,358.56. And that again is equal to b squared. So I know what a equals, I know what b squared equals, I know h and k are 0, 0. So the equation of the hyperbola is just going to be, I don't have a plus sign here, you guys should have corrected me there. Minus. Alright, we got a horizontal hyperbola. Hyperbolas are minuses, right? So minus. So x squared over a squared. So if I type in 148.8 squared, it come out to 22,141.44. Minus y squared over b squared, which is 40,358.56 equals 1. You can be very careful, equals 1 is every one of your answers all the time. Okay, so that's question A done. Okay, moving on to question B. If the ship is directly north of transmitter T1, determine how far the nearest mile the ship is from the transmitter. So again, if I superimpose some axes here, the x and y axis 0, 0, right? And the ship's directly above T1 right here, and I'm looking at the coordinates of the ship, they're asking me for the y coordinate. How far north of the transmitter is it, right? They're giving us the x coordinate, because if this is 0 and c is 250, this is going to be negative 250. So to do part B, I've got my hyperbola equation right here. I'm going to substitute x with negative 250, and I'm going to work out what y equals. So I get negative 250 squared over 22,141.44 minus y squared over 40,358.56 equals 1. Negative or positive 250 squared is the same thing, right? So 250 squared divided by 22,141.44 comes out to 2.8228. I would probably move the 2.8288 over to the right first. So I'm going to get negative, or actually I'm going to move the 1 over. Move the y squared over, just make the y squared positive. All right, so 2.8228 minus 1 is 1.8228. That's going to equal y squared over 40,358.56. If I multiply, cross multiply here, I'm going to get y squared is going to equal the product of those two numbers, right? 1.8228 times 40,358.56. That comes out to 73,565.5832. That's what y squared is, so y is going to be the square root of that. Square root of 73,565.5832. We'll round to a couple decimal places, 271.23 miles. So these long-range navigation is what I believe what LORAN stands for, long-range navigation. These systems, I'm assuming that's how shipping companies work anymore. It's probably that gets everything computerized, allows the computer to use mathematics to guide the ship on a specific path. But again, hyperbola, we have the ability, if we know the equation of hyperbola, we can identify where the ship is at any given point. Along the way, if we know the x-coordinate, we can find the y-coordinate, and vice versa. So that's how to do those problems. So if you see anything about LORAN, refer back to this example.